Welcome, everybody. Welcome to the ISEF class of 2020. It's wonderful to join you. My name is Kumar Garg. I'm a Senior Director and Head of Partnerships at Schmidt Futures and a huge fan of the Society for Science and the Public and of ISEF and a former fellow. And I want to welcome you to our panel discussion, Technology and its Role During the Pandemic. We've got an incredible slate of folks that will be talking to us in this conversation. And let me introduce them now. They are Catherine Havasi, who's the research and entrepreneur in AI. We've got Galen Hunt, who's a distinguished engineer and managing director at Microsoft Azure Sphere. We've got Tom Layton, who's the CEO and co-founder of Akamai. We've got Divya Nag with Apple Health. And we've got Henry Samueli, who's the co-founder and chairman of Broadcom. I'm really looking forward to this conversation because I think we're living through an incredible and difficult and important time, and I think the role that technology is going to play in both helping us get through it, but build solutions is going to be incredibly important. And this is a panel of folks who have lived technology over their careers and are also going to be important parts of the solutions that come. So I really hope we can have a great conversation. Well, Henry, it's so wonderful to have you join this conversation, especially in what will be, I think, a momentous year for ISEF. Certainly, it's an incredible period we're all living through, and I'm so heartened that Society for Science and the Public is still putting on ISEF and doing it in this incredible virtual fashion. But one thing that I wanted to sort of start our conversation with is just, we all have incredible ways that we're sort of experiencing the pandemic, all small ways and big ways. But I think science and tech is really front and center in so many of these conversations. And I just would be curious, as you sort of reflect on this moment for the science and tech sector overall, what are some of the thoughts as having been a leader in it for so many years as to what does the pandemic mean for us as a community working in this area?
Well, for me personally, it really means a lot because Broadcom's core business is creating a broadband internet infrastructure to enable the kinds of services that we're so dependent on today, such as video conferencing, streaming video. We've been doing this. We founded the company in 1991, so nearly 30 years ago, and that's all we've been doing for the last 30 years, because 30 years ago, you would not be having this conversation with me, I guarantee you that, over the internet. So to me, it's something that I'm very proud of, the fact that I had a role to play with all the smart engineers, not only at Broadcom, but a lot of companies around the world, to create a broadband internet infrastructure globally so that we can do these face-to-face interactions. And not only for social reasons, but for business reasons. You're conducting a lot of the global business today over the internet. And video conferencing is a critical portion of it. So without it, we would be in much, much worse shape than we are today.
Yeah, I mean, I think one thing people always sometimes underappreciate is that history always feels inevitable when you've lived it. Like, oh, of course, we are wherever we are. But you've actually seen this sector grow up. And a lot of the technology that we rely upon was actually the hard work and innovations along the way. I'd be curious if you sort of chart back, are there a couple of sort of key, inflection points that you think were key points in the broadband story, that where you're like, we're here with this capability globally because X, Y, and these things happened?
Sure. I mean, it's been a long evolution. It doesn't quite happen overnight, but the key to enabling it is really the availability of semiconductor technology that followed this Moore's Law exponential capability path. Without that, we couldn't build the appropriate signal processing infrastructure to process the video real time, send it over the internet. So that has happened literally over the last 50 years since the semiconductor chip was invented in 1960. So it's taken that capability and evolution of signal processing capabilities, and fortunately Broadcom entered the market at the right time to take advantage of the so-called CMOS VLSI era and apply it to these communications problems of broadband communications. and enable these devices like you have in front of you with your iPhone and iPad and the internet infrastructure in general. So it's hard to pinpoint one key thing, but there was the major inflection point is from Broadcom's perspective is when we transitioned from phone line modems that were operating at tens of kilobits per second to cable modems over your cable TV network that operated at tens of megabits per second and now tens of gigabits per second. That was the major inflection point to enable these types of video services, because you couldn't do it over phone lines operating at tens of kilobits per second. It just didn't have enough bandwidth.
Yeah, I mean, I just think it's incredible to watch innovation happen in a sustained and way over such amount of time. I'd be curious if you were to transport yourself back to when you were the age of some of these ISEF students. What were some of the science and tech ideas that got you excited back then? And do you feel that there's some arc between what you were interested in then and the incredible career you've had?
Oh, 100%. For me, it started when I was in the 7th grade, even earlier than the ISEF, kind of along the lines of the Broadcom Masters Middle School Science Fair program that is run by the Society for Science in the Public. And there in the 7th grade, I was fascinated by radios. I saw these magical boxes that weren't connected to anything, yet sound was coming out of it from around the world. How did that happen? I was so curious by it that I asked my middle school electric shop teacher. We were required to take these shop classes, either electric shop, wood shop, metal shop. You have to build things with your hands. So I took an electric shop class, and I asked him if I could build a radio from a Heathkit project that I had seen in a magazine. He eventually agreed to let me do it. So I bought the project and spent the whole semester soldering wires, following directions, and plugged it in at the end of the semester, and sound came out. And I was so fascinated by it. I made it my career life's mission at that point to figure out how that radio worked. And that's what I did. I followed a career in electrical engineering and communications engineering so that I could eventually figure out how that radio worked, which I did by the time I got my PhD. But the key is having a hands-on project-based learning experience is so critical for young people to develop their career path. And it starts in middle school, goes through high school with the ISEF competition, and beyond into college. And it's critically important because there's nothing better than a hands-on experience to motivate a young kid to get excited about a career opportunity.
Well, I just think it's such an interesting idea, this idea that you got fascinated by one thing and just dug deeper and deeper and made a whole career out of it. I'd be curious, one thing young people will always ask is like, what should I study? This is big crisis. How should I help? How should I organize my time? What should I do? Do you have sort of thoughts on reflecting back on your own personal story of just digging in on something as to how one should sort of approach this question?
Sure. I mean, I knew generally what I wanted to do because of my fascination with radios, but in terms of the specific path I took, it was largely driven by the classes that were available to me to take in college, especially as an undergraduate. And a lot of new fields were emerging at the time, as they are now today. But for me, back in the 70s, when I was an undergraduate, the new fields that were appearing, as I talked about earlier, CMOS, VLSI, very large-scale integration, due to the semiconductor trajectory that was occurring. That was a brand new field. The course was just developed. The very first course at UCLA in VLSI design was when I was an undergraduate. Another field, digital signal processing. The very first course that was created at UCLA was when I was a junior undergraduate. So I took these new courses, not knowing anything about them, and I got so excited about them and enamored with them that they became the career path that I took. So at a large scale, I was stimulated by the radio, but at a specific level, stimulated by teachers and coursework in new fields that were emerging. And today there are so many exciting new fields, especially in the biomedical engineering area, where you're applying engineering technology to the health sciences, especially now dealing with pandemics, et cetera. So I can see a beautiful confluence of engineering and medicine and health for the next 20, 30 years that the kids are going to get excited about. So to me, if I were starting today, that's probably the field I would pursue into the future.
Yeah, do you have good tricks for if you were looking at a course catalog, you're starting to show up on a campus, you're thinking about what classes to take? Did you have a sense of like how you sort of found energy as to what to take?
When I was in school, actually, I didn't have any predetermined ideas as to what specific classes I wanted to take. I came in with an open mind, knowing I wanted to be an electrical engineer, but even within electrical engineering, there's 10 subfields. So I just took a lot of different classes. I took as many classes as I could and found the ones that I enjoyed the most. And that largely is due not only to the subject matter, but the quality of the teacher and how well they stimulated and got you excited over the field. And the ones that excited me the most were the ones I dug deeper into and took more courses in, and eventually selected my major that way, my sub major.
Well, I wanted to, also pull in some great student questions that we got. And I think, one that sort of I thought was just interesting around just you're developing skills, you're trying to figure out how that you can help. It comes from John Lynn from Boston, Massachusetts.
My question for the panel is, what ways can students interact with or develop technological tools to help during a pandemic? Thank you.
It's very much the ISEF mission, which is don't just live in the problem, like try to work on it. What are your thoughts for how students could get involved and sort of start to actually work on solutions?
Oh, absolutely. There's a lot of things that can be done. Maybe not in time for the current pandemic, but certainly in time for the next one. And you can be 100% certain there will be a next one, because in the history of civilizations, we've had regular pandemics every few tens of years, or for smaller ones, and every 100 years or so for major ones. So they do regularly occur. So even if you don't solve today's pandemic, work on the next one. And the areas of need are very obvious from what we've experienced here. First of all, probably the most important is early detection and contact tracing, because if you look at some examples around the world of countries that did it really well, Taiwan comes to mind as one of the best examples, because they have largely been unaffected by the pandemic. And the reason is because they, back in SARS, the previous major pandemic that we had in 2002 roughly, they were affected by it severely, and they quickly came up with these approaches to early detection and putting in social distancing quickly and contact tracing quickly, so that they could quarantine and isolate people who got it to prevent widespread expansion of the disease. And the numbers that they've achieved are quite remarkable. I mean, truly remarkable. And I think we can learn from that, so that how we can quickly detect, identify, and act to slow the spread of a disease, because it does take time to develop the vaccines and drugs to treat it. So you need to slow it down quickly through early warning systems.
Yeah, and this actually intersects well with a second question we got from Jake Park in South Korea.
My question for the technology and its role during the pandemic is, what will be the biggest change in technology in the post-COVID-19 world? Thank you.
Well, I think the whole area of public health, I think, has raised in visibility dramatically. And I mean, public health has been an obviously important field of study for decades, but I think now it's really going to be a spotlight area. And applying technology to public health, I think, can be very interesting. And you'll see a lot more of that going forward, especially in the internet age where everybody's connected digitally, creating the software tools to enable better dealing with public health issues. And I mentioned a couple examples earlier, but I think there will be numerous fields of study opening up related to applying technology to public health that will better prepare us for the next pandemic. And not only the more traditional health-related things by studying vaccines and studying drugs, but I mean, how do you deal with a society as a whole with billions of people to quickly detect and enable social distancing, and doing it in a way that's not disruptive to society, so people can feel comfortable that social distancing, when needed to happen, is something you're okay doing and you feel comfortable doing. Not that we're going to be doing it 24/7 for the rest of our lives, But when a pandemic hits, you need to be quick about it and act in a way and not worry that it's totally disrupting your life. So minimally invasive public or social distancing to me is a huge area of investigation for young kids to get into the future.
Well, as we sort of start to close out, I'd be curious of, you know, obviously doing a virtual science fair is very different than what ISEF usually is, but I think there's real room to innovate as well. Do you have sort of advice for this class of ISEF students for how they should try to get the most out of this experience, especially as a way as the careers they want to develop forward?
Certainly. I mean, when you're getting ready to go to college, I mean, it's important to read up as much as you can about the work that's going on. It's obviously widely available on the internet that you can read endlessly, and try to select the university that you want to attend that specializes in an area that you're excited about, because each university has their own area of specialty, and finding the ones that excite you the most, whether it's, you know, core science of developing drugs, or as I mentioned, public health, or just engineering and computer science, applying big data analytics to solving these complex problems, genetics. There's so many areas to go into, but try to find one that excites you and then target universities that are good at it, and steer your career in that direction.
Well, that's great. Well, I want to thank you, Henry, for taking the time to talk to all the students and for joining this incredible conversation. And, you know, I know that both they'll be enriched by the career that you've had and the inspiration that it provides, but that also, you know, hopefully there'll be a number of Henry Samuelis running around among this
So.
class. And so
No,
the world
I'm
definitely
sure
need
there
it.
will be, and far more successful than me. You know, I've met so many of these kids through the Broadcom Masters and ISEF, and they're remarkable. These kids are unbelievable. I know they will have successful careers, and they will make life-changing contributions to society. So congratulations to all of you. Sorry we had to do this virtually, but I know you're going to take advantage of it to the best of you can, and move forward and really have an impact on society. So congratulations to all of you.
Thank you so much, Henry.
Thank you, Kumar.
Well, Divya, it's so wonderful to have you join us and to join the whole ISEF community. I know that for the students, it's incredibly they're incredibly honored to have so many great folks chat with them. I think it's great that the Society for Science and the Public is putting a conversation like this on, and we really want to celebrate these students for everything they're doing. But one of the things I think you always feel when you're doing this work is, you know, is it just a moment in time, or is it the beginning of something larger? And I feel like you've been on this journey of having worked on science and tech as a student, but then continue to work on it in your career. And I would just be sort of curious about, you know, how long does it, you know, if you can think back to a memory of when you were growing up that really sort of started to build your interest in science and tech, and what sort of harbored that passion.
I love what you said about kind of moments in time being these sources of inspiration. And I think definitely in my career through science, it's really been a lot of that, where my journey, even in high school, started with the birth of kind of forest fires around the world. And I remember just being impacted by, like, what does this mean for us, seeing the ecological devastation happening in countries like Australia, was actually the impetus for the research that later went on to become my ISEF and STS projects. And I think throughout, that was kind of high school, but then in college and even now, how much we're inspired by what's happening around in the world around us. And so in college, it was a very similar story about how I got involved in healthcare, with kind of the birth of stem cell technologies and just the incredible potential that those showed. And I'm actually really excited in today's day and age with the pandemic, to see what sort of innovation comes out as a result of the context people are living in.
Yeah, I mean, I sort of remember this. So I served in the White House Office of Science and Tech Policy under President Obama. And one of the privileges I would get to meet the Science Talent Search students and the ISEF students every year. And I would just sort of quiz them about what got them interested in what they're thinking. And, you know, often it tied back to a personal story. You know, something that happened in their family or something that happened in their community. And it was always both incredibly inspiring, but also just, this is how we find the problems to work on. So I would be just sort of curious about, you know, there's always this element that whenever I would interview the students, they would say is that, you know, adults count us out too much, you know, like, oh, some point get your skills and some point later you can help on these things. But I'd be curious around, you know, what are ways that you sort of took the idea that you could actually work on something like forest fires or something really seriously and actually went about going it, and how you look, what sort of advice you'd have about folks jumping in right now.
Yeah, I mean, I'd say adults often overcount students. And I love that forums like ISEF and STS really help empower students to not only see that it's okay, but to show that students are celebrated and that their achievements can go on to do incredible things. I know a lot of students right now are trying to think about ways that they can leverage STEM and technology to help with the pandemic. And so I think there's opportunity everywhere. I think through COVID-19 specifically, it's impacting local communities and businesses in really unique ways that I think students are at almost an unfair advantage to go and start solving some of those problems. So when I look at even my own community, things like local mom and pop shops are struggling to figure out how do we take our consumable goods or our services and bring them into the digital world. So how can students help leverage technology, create websites, create apps to help some of those local businesses. But even kind of on a personal side, if you think about the people that live around us, how do you help the elderly or people that are living alone and feeling a lot of social isolation? Are there ways that technology can help make those connections, whether it's connecting you to someone that can go and buy groceries for those that feel it's unsafe to leave their homes, or again, just giving people a more personal connection for individuals that would have gotten to interact with people otherwise and now are finding themselves in a situation where they can't. And so I've been thrilled to see, just even on the App Store, like kids around the world coming up with games to make people feel connected, apps, websites, just like how do we leverage the creativity of our youth to be able to solve some of these hard problems.
Yeah, I mean, I'd be curious if you, I'm sure you're seeing a ton of that innovation directly. You know, I think Apple's always done a good job of actually actively encouraging students to build for, rather than saying just on the consume side. But I'd be curious if there are, if you sort of think about your sort of career arc, are there certain things that you got sort of either through ISEF or your high school and then undergraduate experience that end up being mattering the most in your work today, and like what ends up carrying forward in ways that are useful?
Totally. I think at the heart of all of it is people. And so I've been very fortunate in both high school and college in seeking out like-minded individuals that just like are excited about solving big problems. And then with that comes a lot of those people are the ones that open doors for opportunities. So in high school, a professor at UC Davis was just like, I'm also equally excited about this problem. Why don't you come and work in our lab? And that was kind of the genesis of that. In college, it was in the stem cell space, like-minded researchers who are like, is there something else we could do here? And that ended up opening the door to then starting a startup with that technology and trying to find new ways of innovating. So I'd say I think the two things that have really shaped my experience, I think we'll continue to do that, are one, finding these crazy problems that you're just extremely passionate about solving, whether that's forest fires, whether that's biotech, whether it's healthcare, and then two, finding just those like-minded individuals that you feel like you could stay up all night with, trying to come up with creative solutions.
Yeah, I mean, the peer effects I think are so important. I think one question I have, and I don't think there's an easy answer, is, you know, as we go more and more virtual, on one level, we can connect with peers dynamically in a virtual setting as well. But what's your advice for how, you know, the ISEF students can sort of try to find both mentors and peers and others to sort of work with and build passion in this time?
Yeah, I think this is where programs like ISEF are so critical, and I love seeing that ISEF is going to be virtual this year. It's all about how can you find those connection points. And I agree with you. Like, I think this is a novel world, and it's a new world that we're all going to have to navigate through together. But just like you kind of run into people around the office or on college campuses, are there ways for us to have that collision effect virtually through things like Zoom calls, where we just get a ton of brilliant people together and facilitate those conversations?
Yeah, well, this actually intersects well with one of the student questions that we got. So this is from Joaquin Jesus Gracia from Kingsville, Texas. And so what he asks is, how will the progression of technology be affected by the pandemic? Will there be innovations and features that will be put on a halt? And will there be more innovations than before? And, I think it's always hard to see the future, but I'd be curious just, whether you're thinking about it from Apple or more broadly, what's your sense of what the future, what things you think were more possible and ways, what's that future could look like, both on things to work on and things to solve for?
It's a great question. I think given all the uncertainty of today's day and age, it's something that's probably on a lot of people's minds. The question reminds me of a quote that I just absolutely love, which is, necessity is the mother of innovation. And I really think that as you look historically, there are a lot of times of turmoil and darkness, come a lot of innovation that really kind of set the tone for the next decade, 2 decades. And I see this moment as being one of those crucial inflection points, which again, I think is just such an exciting opportunity for a lot of students out there. I guess specific industries that I think are just ripe for disruption in today's day and age, given the pandemic, things like schools. I know a lot of people around the world are trying to think about how do we deliver and disseminate education in a way that isn't just virtual, which we're being forced to do, but in a way that still maintains the engagement and excitement of learning in new ways. So I think the solutions that are going to come out in the next 2 to 3 months, I can imagine it having an impact on kind of our students' kids' lives in the future, which is exciting. Another area that we just talked about was businesses. So companies like Apple are very used to and built on a foundation of collaborating face-to-face. And so now how does COVID-19 kind of help us reimagine how to structure those interactions in a way that still gives you the creativity, but allows for virtual interactions? And then, of course, healthcare. Like, healthcare has very traditionally been a space in which physicians and patients interact in a face-to-face kind of setting. And what are ways that we can use remote technologies, whether it's things like the Apple Watch or other wearable devices, to help create some of that data that isn't going to exist in in-person interactions, and still allow for a really robust and profound ability to deliver health.
Yeah, I mean, I think that's a great list. I mean, one thing that jumps out to me about education is that I feel like students are both the recipients of the failures and challenges that we're facing, but that might also mean that the innovations that they might come up with are very grounded. There are lots of problems which are important problems of the world, but you're many steps away from that problem. Whereas I think students are seeing the limitations of the current education delivery model up close. So I'd be curious, one of the other questions that we got was from Sejal Gupta in New York.
For the panel is, how can I get involved with helping with the pandemic crisis using technology? I want to help beyond donating and making cards. However, I cannot find groups that have initiatives for high schoolers to participate in. Thank you.
One way I sort of add on that is, education might be an interesting area, because that's something where your lived experience might actually give you insights around problems worth working on. But I'd be curious around how you sort of think about ways to approach this question about being the most helpful, or being the most, finding the kind of edge of the problem.
Yeah, I love that. I think sometimes the best solutions come from people designing solutions to fit problems they're experiencing themselves. That's how you truly put yourself in the customer's shoes, to make sure that the solution is not just like something that looks good on paper, but if it's not something that like you're willing to use and live and breathe every single day, then it's probably not something that someone else would want to use. So I love the question from Sejal, and this is where I truly think students have a profound ability to make a difference in today's day and age, whether it's solutions around how to leverage technology for education, but also other ways that you and I had talked about around leveraging technology to really help lift and empower the community around you, whether that's, again, local businesses or other people in need. But then there's also kind of an interesting opportunity to now leverage data in new ways. And a lot of students may not have access to like big labs or things like that right now. But what's been really cool to see is that a lot of institutions like the New York Times are open sourcing big databases around COVID-19. And what I would love to encourage students like Sejal to do is go and check those out and see if, like, one, are you able to see something interesting, like find new insights in that maybe other people have missed, given your unique perspectives and vantage points. And then two, I think a lot of times health information, especially around things like pandemics, can be very scary. And so having students help think about creative ways of even disseminating that information, I think could be super helpful. Thinking about ways that are, again, creative and engaging, because I think there are a lot of people around the world that are struggling with, why do I have to continue to stay at home? Like, I don't understand it. And so taking these large data sets and coming up with interesting ways of almost doing journalism or reporting on it using novel kind of mathematical models or epidemiological models, I think it's just a fun way for students to engage in the conversation and hopefully also help share their insights with others.
Yeah, I've always thought they should be more of like a Kaggle for kids, you know, like what's a thing that allows you to have ready access to data and actually do things with it. You know, I'd be curious, you know, are there, when you sort of think about ways companies like Apple and others could be engaging students, are there things that you'd want to sort of put on that folks should check out?
Yeah, you know, Apple has a ton of programs for kids to get involved, mainly around kind of the app development front. And so I think to the extent that kids are coming up with interesting ways to help either local entities or, again, people in their communities, to the extent that these everyday devices that live in people's pockets can be a helpful vehicle of disseminating that information or making those connections. Definitely recommend checking out a lot of programs Apple's putting out around learning how to code and getting people's apps up and disseminated through the App Store quickly.
It's great. Well, is there a final bit of advice you want to leave the ISEF community for how they should think about the year and the world ahead?
I think it's scary times, and first and foremost, I hope everyone's staying healthy and really taking this opportunity to reconnect with family members and loved ones. But outside of that, just like there are such few moments in history where we get this opportunity to really question why things are the way they are, and if there's opportunity to reimagine kind of the world we live in. And so take your experiences, no matter how big or small, and ask yourself whether this is something that could be done better in the future. I think we all have an opportunity to really influence how the next few generations get to experience the world.
That's great. Well, thank you so much for joining us. I know folks will be thrilled to have you. Well, Galen, it's so great to have you in this conversation, and I really want to thank you for taking the time. I know the students will be excited to hear from you. You know, I think one of the things that just in the crazy time that we're living in, with everything going on with the pandemic, it's just important to think about how do we make the biggest difference that we can. And I think one of the things that I think is probably hard for people to fathom when they're at this age is just like a full career that they can have and a career of impact that stays before them. And I think yours is a great example. So I figured one way we could start is actually take you back to being at that age, and what were some of the ideas or ways you interacted with science and technology that got you most excited. So were there particular things that got you really hooked on tech that you sort of remember back to?
Well, the thing that got me hooked on tech was the very first time that I had a chance to actually interact with a computer. So when I was in 7th grade was the first year that our school district had had computers. And, I realize in saying that I'm kind of dating myself, and that, that was a few years after they invented the wheel, and fire had come along, and now we had computers for the very first time. And the first time I saw a computer and was actually able to sit down and type in a program, just, really simple, basic, print hello, go to 10 loop kind of thing, just gave me this excitement of, wow, I can interact and I can make something happen on this computer. Was a really compelling moment for me, and then became this lifelong love of computing.
And do you remember, I mean, what were some of the projects that got you interested that you applied under ISEF for?
Yeah, so I was an ISEF alum in 1986 and 1987, last century. And one of my projects was on computer viruses. I think I may have done the very first computer science or science fair project on computer viruses. And then I also did a project on looking at DNA sequencing and trying to do really kind of more thought experiments than anything else at that time. And so now it's something we do really, really well with huge cloud computers, and wasn't something you could really do very well on an Apple II, let's put it that way.
And do you remember peers that you sort of interacted with at the time that were excited about computers with you? Or was this something where, most people that you said, hey, I did this thing on a computer, they'd be like, what are you talking about?
Well, there was a small group of us that were really excited, and we would all come in the early, and so none of us had computers at home. There was just these three of them at the school. We'd show up early before class and use the computers for a while, and at lunch and after school. And we all recognized each other because we all had a floppy disk that we would keep our programs on. And also, we were nerds before nerds was being cool, definitely.
And I'd be curious, do you even remember when you were at ISEF, how many other sort of folks were doing anything on a computer that year?
Oh, it was, I don't know, ISEF maybe 30, 40.
Wow.
I mean, it wasn't like computers everywhere, right? It was a very small number of.
Right.
Yeah.
And what's your sense that when you sort of look back as to what got you hooked on sort of working on this and building a whole career out of it, were a key set of experiences that really sort of solidified your interest?
There was literally kind of that first experience of just putting my hands on the keyboard and typing in a program. That very first time you type in a program and you hit run and you can see the computer do something, that was a pretty compelling experience for me. And then there was a transformational time for me when I got into college, because in high school and that before I programmed and even done a little bit of professional programming. But when I got into college, I actually was going to do physics. My dad thought doing physics was a good thing, and the computer, he wasn't convinced the computer science thing was going to pan out. But I shared with people a couple of years ago. My dad actually asked me one day, "So, the internet thing, do you think it's a passing fad?" But so, and at some point I realized, well, I'm never going to be a great physicist, because to be a great physicist, you just really have to have a fantastic mathematical mind. And I found I had an average mathematical mind. Okay. But at the computers, it was something where I was passionate about and I could make things happen, and, then I got into as I discovered computer science, which wasn't just writing programs, but actually what kind of problems can we solve with computers, and how can we go about that? And that became a very transformational thing for me.
Well, I love the story about your dad, partly because, we're always getting advice, whether we want it or not, about, oh, do this, don't do that, or others. Do you have sort of thoughts? We're going to violate this rule now, because I'm going to ask you if you have advice, but do you have sort of thoughts about when somebody's trying to think about, well, I'm passionate about this, or I want to do this, or how do I have an impactful career, or how do I make a difference? How if you were giving advice to your younger self or something else, how would you sort of approach that question?
Well, I've learned two things I think are really, really important. One of them is, and I've kind of already hit on, is follow your passion. Figure out not just like what you think is an important problem, but or an important area, but what are the things that just get you really excited? One way I've heard it described is when you have absolutely nothing else to think about, what do you think about? For me, when I had absolutely nothing else to think about, like daydreaming time, I would think about writing programs. Okay, still do. Okay, and so clearly that's where my passion was. When you have nothing to think about, if you think about viruses and and biotech, go there. Follow the passion. I think is a really important thing, because what I found is people who are passionate about something are productive, because the cycles go there, the brain, the creativity, and everything else. And the other thing I found really important is a rule. I call it follow the pain. And that is, when I reach a point where I end one project, I'm beginning another project, I give myself time and space to really think about it. I've told people, you can't program creativity, you can't schedule creativity, but you can create time and space. Give yourself time and space. But follow the pain is go look for a problem that exists in the world where something's harder than it should be, or more challenging than it should be, or more difficult, or that it's just feels wrong with the way the world works. And then say, well, how can I apply my passion to that problem? And you have to have that mix, right? You have to have both an important a problem that's a problem, and the passion that some way to solve it. A side note, physics. I was going to go into. I was really interested in physics to start with, because I wanted to help create fusion power, right?
Mm-hmm.
Well, luckily, I think I did make the right choice, because that hasn't panned out really, really quickly. But also, I didn't have the right skill set to go address that particular problem. And so the world's better off because I went and solved a problem that I could solve. And I've had a fantastic time doing it as well.
So, I think the follow the pain ideas sort of intersects really well with one of the questions that we got. So this is from Vivian Chinoda from Zimbabwe.
What are the scientific advancements, or to be more precise, the technological advancements you think will result from this global pandemic we're currently facing? Thank you.
So much about the pandemic is about the difficulty of going through it for so many people in a variety of contexts. And what are ways that you think that might actually create the kindling for innovation, and what might come for solutions?
Yeah, Vivian asks a great question. And as I think about it, I kind of think of the areas of medicine and virus. I'm expecting we're going to see a huge transformation in the biotech field around creating vaccines and things like that. We've already seen some amazing progress just, this year, but I expect to see real transformation of how we even go about solving those problems. There's the tech side of remote technology, video conferencing, and things like that. I was in a meeting yesterday, and someone was telling me the Microsoft Teams organization, in 4 days, they went from using about 500,000 servers to using over more than 3 million servers just to support all the people. So we've seen these advances of kind of the amount of work you'd see in a decade happening in just a very, very brief amount of time. I work in IoT, Internet of Things, and it's the ability to connect the physical environment to the digital environment for remote monitoring, all sorts of things that we can do. And we're seeing huge advances there of, it is a recognition that you're not always going to be able to have people where you want them, for example, or necessarily want people to interact. And so accelerating that remote technology. And then I think the other place where I have no idea what the changes are going to look like, but I think societal and the way we interact, we've all now figured out how to do video conferencing really well, and that maybe it's a lot easier to do a video conference rather than get people together. And also we've kind of figured out what's important to us about interacting and what's not. So I expect we may see some very fundamental changes happen there.
Yeah, so this actually intersects with the other question that we got, which was a question from Brianna Bronson from New York.
My question is, how can we stay connected to the scientific community, even if we can't be in the lab doing research right now?
So Well, we've seen a real transformation in the way we work. Like just my work group at Microsoft, for example, we formerly always worked in opposite. Microsoft has always been what we call a very Redmond-centric company. It's like everybody literally being in the same, as close as they physically could possibly be, so you could rub shoulders and interact and have spontaneity there. And we can't do that anymore, but we've learned how to, do video conferencing really well. We have like teams that like have chat windows open all the time. There's one of my sub teams, they actually keep a video conference on their screen all day long during work hours. So these are people who are mostly programmers, they're mostly writing code, but they keep a video screen so that they can just raise a hand and other people see them, for example, if they have a question. And so there's different ways that we can interact. One of the interesting things too is because it's erased, because everyone now has physical boundaries between them, it means that, there's not like the room where the conversation is happening anymore. It's actually can be a much more inclusive environment in this way. So I think we've learned some great things on how to work that way.
Yeah, I mean, I think there's always a big question around how one sort of adapts in this environment. I mean, I remember from my White House days in the Office of Science Tech Policy that basically if you couldn't be physically in a meeting, people would tell you, oh, we'll give you the notes.
Oh, yeah.
Yeah, no matter how much it mattered. And so, just yesterday there was, the second week of a teleconference for the Supreme Court. So, what's possible and our expectations are quickly shifting. I guess one way I'd love to sort of finish out was, I think it's always hard to know what are the things you're going to work on that are going to end up mattering the most. I remember when we, before we started our conversation, you were mentioning your graduate project. And I figured that'd be a great way to close out. If you want to talk about what you did as your first Microsoft project and what it became.
So my intern project, summer of 1995, was building the prototype for what became this program called as Windows Media Player. So it was the first time of streaming video to PCs over the internet. And it was, I'd been started
totally not relevant in the modern age.
Totally relevant. But it started out at the time people were talking about streaming video over fiber optic. They had not figured out how to do it over the internet. And a guy came into my office by the name of Rick Rashid, who ran Microsoft Research. And he says, Bill Gates and I were having this conversation about could we stream video over internet? You're an intern. Why don't you go figure out, see if you can do it? And, within a couple of weeks, I had a prototype for the very first time doing this video streaming over a pretty low bandwidth. And it's become relevant for all sorts of things. I've had a number of other opportunities in my life. For example, discovering early cloud computing came out of a similar thing of just looking for a problem and then finding something.
Right. Well, I think if it's incredibly inspiring because, we don't know the things that we work on and what they'll become. Your idea that if we bring passion to them and purpose to them, it can have this immense impact over time. So, well, I just think it's a good lesson for the current age because we don't know what the future brings. So I want to really thank you for taking this time with us and for all that you're doing directly and for the inspiration you'll give these students.
All right. Thanks, Kumar.
Thank you so much for joining us in this conversation. I know the students are going to be thrilled to hear from your perspective. And do you remember some of your key science fair projects you did over the years when you were in high school?
I do. Yes, I definitely do. I think, I did weather forecasting once, which was particularly cool. I did the control systems for doing theater lighting, which was also particularly cool. Those were two that I definitely remember and think about. Nothing I did was really as focused on language as I ended up being. And I think making that transition, which was sort of, if you think about how we work and how we talk and how we interact, if you're interested in that, pretty quickly you get interested in language.
What's your sense, if you think back to that time and you sort of said to somebody, I don't know if this clicked for you in high school or after, but this idea of starting to get interested in neural networks or what became the kind of base roots of machine learning and AI, did you have peers at the time where you were like, oh, I have a set of people to talk to, whether it's other students or others, or like, who did you sort of interact with, given that, now it feels like it's everywhere, but back then, I don't know how many people were on this wavelength.
Right. So for me, the first time I met people like that was actually at the science fair, at the International Science Fair. And so that was tremendously important. And hearing how they addressed learning more about things, hearing how they got support, hearing what they did was actually really eye-opening for me. I didn't come from a place where people did a lot of science like this. And I think it was really exciting to go there and to meet peers. And that was tremendously important. And we kept in all of this probably sounds so antiquated. We kept in touch through, instant messenger and email and all these things that you did in the 90s.
Right.
And, just continuing to talk to them about what we were learning, things like that. It was really important.
One thing that sort of jumps out to me in that is that there's a whole social dimension to how do we get excited about things and work on them. As obviously that looks different in a virtual science fair, but if there was advice you were giving this community of young people around how they should act on their passions, pursue different interests, try to find peers to work with, what would be your sort of advice there?
Go out and meet people, even people who are, I think this is something that I learned only towards the end of my science fair career, and much more so later, which is meet people who are doing things that are very different than you, who are equally passionate about what they're doing. And a lot of the best work that I've ever done has been cross-disciplinary, has been by learning something in a different field and trying to apply it to the field that I'm in, and getting different perspectives. So really go out there, meet people who are like you, that's important, but also meet people who aren't like you, and really talk to them about how they think and what makes them excited and what drives them. And I think that can really open up a lot of interesting ideas and doors.
Do you remember a fellow science fair mate or someone else that you was doing something very different that really resonated for you?
A bunch of us kept in touch. I went to MIT for undergraduate, so a lot of folks from the community went to MIT as well, and we had a mailing list. We chatted online. We kept in touch pretty regularly well into like freshman year, and I think that was also helped the transition to going to college.
The other thing that always jumps out to me is, sometimes things look so obvious in retrospect. It's like, oh, you were studying neural networks, and what's your sense of when it's much harder when you're thinking about what am I passionate about, what do I want to work on, maybe I want to help on things like the pandemic. What's your sense of like what that discovery process should look like, given that, I'm sure when you were starting down this path, it wasn't like, oh yeah, of course this is going to be the big thing that's going to drive science over the next couple of decades.
Yeah, I think for what I was doing, and mentors became really important as soon as I got to college, right? And I think being able to talk about what I'm passionate about and being able to understand that, even beyond what I was doing, there are fields like natural language processing and computational linguistics that really align with my interests. Learning about those kinds of things from mentors became really important. When I came to college, starting to do undergraduate research in an undergraduate research program was really pivotal for me. And this is, my story is a little unique in that what I started as my freshman undergraduate research project, I'm still working on 20 plus years later.
Right.
And that's not usual, right? But certainly the ideas that we had there and the things that I realized that I was passionate about there have been things that have continued to be a thread, even as I've picked up other threads and different things have changed. So I think mentorship
and draw that link between your work and the company now and the work then. Like what's the arc that you feel like sort of carries over to your work today?
Yeah, I'm always really interested in teaching computers to be more like people and less like what you think of as a stereotypical computer. And, that comes all the way back to how I got into AI in the first place. And, I think that when we started, for context, I run a very large open data project called Open Mind Common Sense, or ConceptNet, that I've run for 20 plus years. That's a resource that people use to do machine learning. When we started working on that, I don't think we knew what was going to come down the pipe, and I don't think we knew where the field was going to take us. But and in that sense, getting into machine learning was something that came natural with, well, how do we apply all this data we've gotten? What's the best way of dealing with this? What's the biggest impact we can make? The stuff that I'm doing these days, outside of Luminoso and DeLong and more at MIT, is also going back to all the way back to what I was doing back in almost the science fair days, and that I'm very interested again in computers and creativity, right? And I think creativity is this interesting thing that we've only started to explore with generative machine learning and computers right now. And so I've been doing work recently on, how can we make computers be part of the design and performance process rather than just a tool. And
Right.
I feel like that harkens back more to what I was doing in high school than many of the stuff that I've done since. It sort of puts everything together.
That's incredible. So one thing that I think intersects with one of the questions that we got from the students is this whole question around, what is actually relevant in the context of this pandemic.
Yeah.
And, I think sometimes there's a lot of like, ideas around, is AI going to solve everything? And I'm not, and I think Jerome Arreola from Guam had this good question, which was, what are ideas to consider when you're actually thinking about developing technologies during these times? If you create tools that are poorly thought out, they might end up being useless or worse. And what are ways that you, at least in the fields that you sort of interact with, think about what is utility now, what is utility in the future? What are ways to sort of be impactful?
The number one thing that when I work with students on this is, as technologists, we can be very tempted to build first and then, think about and talk to the people who are using the technology later. And I think when we want to be successful and when we want to be impactful and when we want to understand how what we're doing affects people's lives, and it always does, we need to talk to stakeholders, and you need to do that in the beginning, right? If you're working on things with the pandemic, and I saw this happen again and again in AI and other fields, talk to the folks on the front line, understand what their needs are, talk to the people who are being affected by the technology you're creating. Always talk to stakeholders, talk to your customer the whole way along the journey, and make sure you think and understand about what they're saying and come to those sort of discussions with an open mind. And I think that is tremendously important as a technologist.
This kind of, it has a democratizing element too, right? Because actually reaching out to people and understanding what their challenges are is something that a lot of people can do. You don't have to start necessarily with the solution. I guess one other, you were sort of talking about, the role academia plays, MIT and others. I think every institution is dealing with this in a different way. But William Pan from California sort of asked this question around, for some projects, the labs are actually shut down. And I don't know if you have thoughts on, what both how people are compensating for just the fact that work is so disrupted, both research and others, but what are ways that folks can think about how to remain productive in these times?
Oh, we're very shut down right now. And, when we were going through that process, it was difficult in large part, well, for obvious reasons, but also because we didn't know how long it was going to happen. And how long we were going to be in that state. So, I do machine learning. We took all of the GPUs out of our server room, and they're in people's living rooms now. They're downstairs. And I think we've all found, and I feel like I haven't been that affected because other than, power balancing issues of taking these things and putting them in your house, that's minor compared to what folks who are working in things like neuroscience or biology are dealing with. And I think we, all need to understand that we should find interesting ways to move forward, to talk to your mentors, see what they're doing. Everybody has plans. Everybody's been working pretty hard on coming to fruition on what that means. And this is not forever. We're eventually going to find ways to come back and be able to work in a lab again. And I think that's something that everybody's looking forward to on many levels.
Right. Well, I just, one other thing that I figured as we close out, it'd be great to cover is, you've had a really diverse career, spending time, both as a, on the private sector side, on academia, on, spending time in government. And I'd be curious around both what motivated you to get these variety of experiences, but also what your advice is on as people try to build their careers on this.
I think one of the things that I've always been really passionate about as a scientist is seeing the stuff that I do make a difference. And I think that means that sometimes you follow it out of academia when it's leaving. And I think that you can get different stuff done in different environments. And when I really think over my career, I think one of the things that you have to really watch for is that your reaction to different opportunities can basically be your reaction to being pushed out of your comfort zone. And to sort of understand that and watch that and think about that reaction as being something that might be healthy for you and might be a new opportunity for you rather than just to be something to be afraid of.
Do you have a good sort of tip or trick for the ISEF crowd on how to deal with being outside your comfort zone?
I wish I did. I think it's something that, I had to learn over time. I think almost every opportunity that I regret not taking, if I look back on it, almost fits like it fits that mold. But really, one thing to remember is that no matter what you do, there's a bunch of different ways to look at what you're working on. And you want to be very cross-disciplinary. You want to try to take things from one place and bring those lessons with you to somewhere else. And if I wanted to leave people with anything, it would be that.
That's great. Well, thank you so much. I know this community is going to benefit immensely from those insights and from your work. So I really appreciate it.
And thank you so much as well. I'm very happy to be here virtually.
Well, Tom, I want to thank you so much for joining us in this conversation. And, I think as I reflect as to the kind of times that we're living in, obviously it's very hard to predict the future, but I think this will be a seminal moment for the globe and for humanity as to how we respond to this crisis. It's incredible that the Society for Science and the Public is bringing this group of students together, all of whom are thinking about how they can use their talents, their passion to solve problems. I thought it'd be good for us to just kind of go back to when you were at their age and what were some of the ideas that got you excited, and it could be small things or big things, but do you have memories of yourself when you were that young, and what sort of got you interested in science and technology?
Some, yeah. And I remember ISEF being very impactful. I went twice, once when I was a sophomore in high school, once as a junior. It was great to be able to engage with other, really smart and interesting kids from all around the world. The ideas and the problems we were thinking about then, are just very exciting. These were the hardest problems of the day. And, when you're that age, anything is possible. And you bring a fresh view to solving problems. And you're not yet jaded in any way that, oh, this is a hard problem, so I can't solve it. And right. That is a key ingredient in innovation and making change, is that you come with fresh ideas, and also the hope and the belief that you can solve it and make a difference. And then you do, I think, in part because of that outlook. And ISEF is, attracts and brings together the world's best minds that will be solving the world's hardest problems in the future.
Do you remember what your projects were in your first
Oh,
few years?
Sure. I was working on 2 math problems that to this day have still not been solved. I was naive enough to think that I might get there. One was Goldbach's conjecture. And this is a conjecture now over 200 years old that says that every even number can be expressed as the sum of 2 prime numbers. So, for example, 10 is 3 plus 7. And people have used computers to check zillions and zillions of even numbers, and for every one, they can find a way to write it as the sum of 2 primes. And so people, I think it's probably true, but haven't been able to prove it. And I was using some statistical analysis ideas to give more evidence that it should be true. The other problem also remains unsolved after a couple centuries, and that was the conjecture that there are an infinite number of twin primes. And a twin prime is a pair of prime numbers that differ by 2. So, for example, 11 and 13. are a twin prime. And again, I was using, some algorithms and some, statistical analysis to say that indeed there should be an infinite number, but no one's been able to prove it, even today.
And just to sort of play this one out, a lot of internet security is actually built on math.
Yeah.
Were there interesting connections between your early interest in math and where you ended up?
Oh, definitely. And, prime numbers, it was only a very few years after I was at ISEF, and I think it was 1972 and 73, that the RSA crypto system was invented. And of course, that relies heavily on prime numbers. And all of modern cryptography today, everything on the internet, now relies in some way on the number theory, involving prime numbers, challenges in factoring, and hard number theory problems. And of course, mathematics and computer science and algorithms underlies pretty much everything that the internet does, not just security, but the algorithms needed to deliver vast amounts of content to people all around the world at very high quality levels. That's all there's a lot of science that, underlies that to make it be possible.
One of the things I think is just fascinating about science and tech as an enterprise is that you can't actually tell where it's going to take you, right? And so if somebody said, oh, I study prime numbers, you wouldn't know that that's going to be the backbone of the internet economy and how we sort of do security. I'd be curious about, if you were giving advice to somebody who's sort of at ISEF and they're thinking about, oh, what should I study, or what should I think about, what I worry about, what should I build? Given how varied careers can be, what is there advice you would have given your younger self?
Well, I'll tell you the advice that someone gave me and the crew of students, at the Intel or Westinghouse Science Talent Search, which is sort of a sister competition to ISEF. And this was Glenn Seaborg, who's very famous in nuclear power, ran the Atomic Energy Commission back then. And he was speaking to the students and said, I'll never forget, he said, you never know what's going to happen in your life, the twists and turns, and your opportunity to make a breakthrough that makes a difference to the world. But he said, what you need to do is keep your eyes open, your ears open, and your brain turned on. And if you do that, you're going to encounter amazing opportunities, problems that are very important and very hard. And if your brain's turned on, and if you're listening and looking, you might solve that problem. And it could make a difference to humanity. And I really think it's true. And I think it's a great message for this group of students, because they are the ones that will define our future and make the breakthroughs. Someday, for example, stopping pandemics before they become pandemics, finding cures to diseases that impact very large numbers of people, combating global warming, nutrition issues for the world, some of the problems that impact many, many people. And these are the students today that will address those problems and solve them.
Yeah, so let's surge forward to the present. Obviously, this is a big moment for the tech sector in general, but then with everything sort of, we're relying more and more on everything online, whether it's work, learning, how do we get, food, supplies, everything else. Are there things, obviously in many ways you were built for this moment. What's your sense on how, as, when you're sort of thinking about the business side, how the company is sort of reacting to this moment, and what's been surprising to you versus not surprising around the surge of sort of online use, and what security looks like in this current age?
Well, there's been an incredible increase in reliance on the internet, which is not really surprising if everybody's sort of locked up at home. We use it for work, we use it for school, we use it for entertainment, we use it for social networking, just about everything. And I think the increased reliance on the internet, a lot of that will become permanent going forward. More and more shopping will be done online, all transactions. And it's great that the internet has worked so well. And a lot of that, as I mentioned before, is really the scientific breakthroughs to enable that. And, it's the kind of thing that when you're at ISEF, you don't think of yourself as being the person that's going to make those breakthroughs for the technology of the future, but you are. And you think of yourself as studying, I don't know, biology or math or physics, and you can't possibly think about how that is going to solve a problem, well, for example, in the internet, and helping make the internet do what it can do, but it will. That it's, there will be breakthroughs that come in areas that you don't expect. And today, of course, security is very important. The bad guys have figured out how to exploit vulnerabilities in the internet to steal information, to steal money, to take over accounts. And unfortunately, those kinds of attacks have gone up quite a bit as well. And so there's a lot of innovation that's needed to help secure all the transactions and our information and the things that we're using the internet for today. And that's going to take some very creative minds. How do you make it so that people can't steal stuff online?
Well, I also want to just, there's an incredible amount of interest and energy by the students who are part of ISEF to be part of the answer. And so one of the things the Society for Science and the Public did was actually ask them questions for what they would love to learn more about. And I thought this one from Anani Raghavan in New Jersey was good.
My question for the panel is, what technology do you currently believe is the most promising for the containment of this coronavirus pandemic? Thank you.
Obviously, that comes with a caveat that there's lots we don't know, but are there things that jump out to you as areas of strong interest?
Well, certainly biology, really important in the medical fields, in terms of a vaccine, in terms of diagnosis, testing. Do you have the disease now? Did you have it? Models for what the disease will do. So beyond biology, I think computer science is very important. Algorithms, statistics, mathematics, modeling, all are going to be very important in terms of, making it so humanity can avoid these kinds of situations in the future. And I think we will. I think this, pandemic is a real wake-up call. We've all known that it could happen, but we haven't taken it seriously enough. And I think we will now. At least I hope we will. And there will be a lot of scientific breakthroughs that, so you won't have this happen again in the future.
I mean, I think this is a really good sort of example on obviously biology is important, but what else needs to be part of it? So this is a question we got from Ziyin Zhang in China.
My question for the panel is, do you have any suggestions on which other skills to learn other than wet lab? Since during the pandemic, a lot of researchers couldn't conduct wet lab experiments nor do field study. Should we learn math, physics, coding? Thank you.
All of the above. Computer science, and that's not just coding, but the science of computer science, algorithms, is really important. And today in biology, it's, the lab is important, but equally or even more important is the computer science aspect of it, the mathematics aspect. A good understanding of physics at the molecular level is very helpful. And the breakthroughs will take place, I think, largely by people that understand cross disciplines and how you can leverage the power of computing today to make the breakthrough in medicine and biology. So that's where all the action is, and I think it's really important. So obviously you want to learn biology, but it's more than just that. I think you'll be much stronger with a broader base.
I think one thing that I'd love to sort of close with is just, one thing that we are struggling with is this whole question of security, right? And it's something you've spent a whole career thinking about. Obviously this intersects with this question around what does security look like when it comes to biology, which you know, I think now people are much more aware of this threat. Are there ways that, as you sort of think about, the sort of crazy period we're living in, that democracies and others should be thinking about the security implications of technology, but in ways that are both responsive but also balanced?
It's a big subject. Security and biology. Just think about your genome, which has a lot of information about you that is very important, very sensitive and personal, and very valuable in the wrong hands. And how, for example, do we do study of the human genome so we can make advances in medicine, but also protect the privacy of the individual? And there's been some breakthroughs there already. How to apply cryptographic protocols to allow researchers to process human genomes to make the medical breakthrough, what genes cause what disease, for example, but not reveal information about any individual. More broadly for our society, there's huge challenges around protecting our privacy online, even as we want to socialize online. We want to buy things online, but protect our credit cards and information about ourselves. And of course, beyond that, how do you protect the quality of information online? How do you have an election in this modern world where people are getting truth? And of course, truth is up for debate. What is true? It's things we could not have imagined when I was at ISEF are really hard problems today that are impacting our society that are going to need important parts of the solution will be technical and technical breakthroughs. Is just incredibly important, I think, to the future of society.
Well, that's great. Thank you, Tom. And I think your career can be a real inspiration to this group of students. And, I'm incredibly proud and interested in seeing what they'll accomplish. So thank you so much for joining us.
No, thank you. And good luck to all the students. I'm sorry you can't be there in person this year, but you have a fantastic future ahead. So thank you and good luck.
Well, thank you so much. And thank you to this incredible panel for this conversation. I'm heartened by, all the experiences that we learned about, how everyone got turned on to science and tech in different ways and how they carried that forward through their careers. But I'm also heartened by how much they think this class of ISEF can do in the world and all of their ideas and encouragement. And I really hope you take that forward into the career that you want to build, but also the connections and peers you're going to connect with through this and the steps you're going to take to really step up. I'm really looking forward to getting amazing updates from what this class of students achieves. So with that, let me thank this incredible panel. Let me thank all of you, and I look forward to staying in touch.